things. I hope my screen is visible to B class as well as A class. Is it my screen is visible? I think in B class it's okay. Yes, in both the classes it's recording started. Yes. Can anyone tell me what we have seen in the last lab class? Hello? Hello? Am I audible? Last class என்ன பார்த்த லேப்ல? எல்லாம் இருக்கீங்களா? தூங்கிட்டீங்களா? Hello? Last class என்ன பார்த்தோமா? What we have seen in the last class? How to draw a circuit in the multisim. Okay. Please, can anyone help me how to get into the multisim software? So this is my browser. What I need to type? Multisim online simulator. Am I correct? Which one I need to click? Online simulator I need to click. Okay. Since I have my own account, whether I need to click a login option or sign up option? Login I need to click. See, everyone do login using your personal mail ID or official mail ID, which one you have created successfully. Let me log in with my mail ID. Yes. So here you will find the things what you have drawn already. Am I correct? This is the very first diagram we have drawn. So if you want to see what we have drawn in the last class, simply click that particular exercise and click open circuit. You will find the circuit. Am I clear? I think this is the very first circuit we drawn in the last class. It's a simple simulation of your one lamp control with one switch. Can anyone tell me how I can start do the simulation? Which button I need to click to make this lamp to glow? Any idea? The simulation run panna, what I have to do? I have to click run button. So if I click a run button, lamp doesn't glow because I have applied very low voltage. So thereby I'm going to increase the voltage. So if I increase the voltage to 1 volt, how the lamp glows? Am I correct? So this is the very fundamental thing what we have saw in the last class. From where you will get the components, So from the left hand menu bar, if you click each and every icon, you will get some set of components required for your experiment. Okay. Then I hope we did the second experiment as our experiment number 1. What is our experiment number 1? Can anyone tell me? What is our experiment number 1? Yes, characteristics of PN junction diode. Yes. So this is where is our circuits? Here is our circuits. Click my circuits. The second one is the characteristics of PN junction diode. Okay. Whether we completed both the biasing or we did only the forward biasing. See, that one was not saved properly. Don't worry, we will draw the circuit without no time. We can draw the circuit. Can anyone tell me what are the components required to bias your PN junction diode? Can anyone assist me? What are the components I need to fetch from this component list? What is the first and foremost thing I need to fetch? Power supply. DC voltage or AC voltage I need to fetch? DC voltage I need to fetch. Followed by I need a diode. Yes, I have selected the diode. Then what else we need? Can you refer the circuit diagram by your own? Are you having the circuit diagram in your hand, dear students? Can I absent and please take down the circuit diagram. This is our circuit diagram. It consists of one input power supply, resistor, diode, voltmeter, and ammeter. Okay. Yes. Now we are going to take. Now we are going to take what? We have power supply and diode. What else we need to fetch from the components list? Can anyone assist me? A resistor we need to select. So simply if I click R, I will get resistor. Am I correct, sir? Or else go to this component list and fetch the resistor. Okay. Then what else we need? We need a ground. Am I correct? So how to get the ground? Simply if I click Z, I will get ground. So these are all shortcut keys only possible in your desktop or the laptop, not with your mobile phone. Okay. Now we got all the components except voltage and current probe. Okay. Let me connect the elements together. How to connect these two? How to connect my source and resistor together? Can anyone help me? How to connect this voltage source with the resistor? We need to bring the cursor nearby to the diamond symbol. So if I click diamond symbol, from where I can take my wire and I have connect the other end of the wire to the another end of my element. Okay, so I have connected my voltage one end of the positive terminal of the source to the one end of the resistor. Then followed by the other end of the resistor to what I need to connect? Anode terminal of my diode. Then how to finish the circuit? The cathode terminal of the diode. Where I need to connect, sir? I need to connect it to the negative terminal of my source. Am I correct? Am I correct? Yes. Then what we need to do? We need to make one reference point. That is, I need to connect my reference terminal with the negative source of my input power supply. Is it clear up to this? Is it clear up to this? Anyone having doubt up to this? So, very first thing, I am going to carry out the forward biasing. Therefore, I have connected the positive terminal of the source to the anode terminal of the diode. Okay. How to measure the current? Can anyone tell me how to measure the current? How to? I need to take the probe. So this is my current probe. I can place it like this. Okay? Yes. How to measure the voltage, sir? How to measure the voltage? How to measure the voltage? Using voltage probe, I can measure the voltage. So, in voltmeter, we know the definition. The potential difference between two terminals is called as a voltage difference or voltage across the particular device. So here I have only one probe. How to fetch the another probe? So V minus is our reference probe. But by default, this V reference probe is my ground probe. Okay, if I select this W and check the item, the reference voltage is by default it is ground. Am I correct? Can you see this? Can you see this setting here? What is the reference terminal of this voltmeter? It is by default it is ground. Am I correct? So I no need to select the negative probe and keep it in the ground. I no need to keep it like this. If I am using my reference terminal as the ground, I no need to put the second terminal because by default it will take it as a ground. Okay, is it clear to everyone? Is it clear to everyone? புரியுதா? இதோட other end ground தான் அப்படின்னா I no need to take the negative probe. Okay? Okay? But if you use the negative probe, nothing wrong. You will get the same reading. I will show you Using the negative probe and without negative probe, what you are getting the reading, we will see. Okay. Can anyone assist me? Here I have finished everything. For better clarification, I can make these labels as the reading what we are going to measure. This is the forward biasing current. Am I correct? I am going to label it as EF. What about this voltage labeling? Voltage labeling, what we can label? I can label it as VR. Is it clear, sir? Is it clear? VR, VF and போட்டுக்கலாம் forward biasing. Okay? Is it clear up to this? யாருக்காவது டவுட் இருக்காங்கன்னா ஆப்சென்ட் ஆனவங்க இல்ல லாஸ்ட் கிளாஸ் ஆக்சஸ் பண்ண முடியாம வெயிட் பண்ணியிருந்தாங்க எனி டவுட் அப் டு திஸ்? ஆனா இது வரைக்கும் யாருக்கா டவுட் இருக்கா? உதயராஜன், மகேஸ்வரன், Prasant, any doubt up to this? Hello? Hello? Tamilan? 254, is that doubt?
No, sir.
No. Shall I proceed? Is it everyone is doing parallelly by sitting in the opposite side? எல்லாருமே அதை ஒர்க் பண்ணிட்டு இருக்கிறோமா? யாருக்காவது டைம் வேணுமா to finish this circuit up to this? Anyone need extra time? Thereby I can wait for some minute. By the time you people may finish this. ஆனா இது வரைக்கும் யாராவது முடிக்காம இருக்கமா? Hello? I hope everyone can draw the circuit diagram very simple. Let me give one more minute time to finish the circuit diagram. See if you are doing the work with the mobile phone or the laptop, don't worry to do the simulation. Usually we will annotate our workspace with our, what we will first type here. First we will type our name. First we will type our name, followed by the register number, followed by the experiment number, and then today's date 4/16. Am I correct? 2021. So in annotation, how we made this? Click this analysis and annotation option. There you will find the text annotation. Okay. Is it you people have finished the circuit diagram up to this? If you have finished, please say yes. Thereby we will proceed. Quick. ஆனா இது வரைக்கும் யாராவது finish பண்ணாம இருக்கமா? Hello? எல்லாருமே டிரா பண்ணியாச்சா அப் டு திஸ்? ஹலோ, நான் பேசுறது கேக்குதாடா? யாருக்கா டிஃபிகல்ட்டி இருக்கா இது டிரா பண்றதுக்கு? Yes, okay. Let me proceed. Okay. What are all the readings I have to take? So let me refer the tabulation once. What are all the readings I need to take? It's very simple. We need to change the input voltage. Thereby, the voltage drop across the diode and current through the diode will vary. So you no need to bypass this one. So this is the input thing what we are going to give as an input. So obviously serial number, then first column input voltage, the second column the voltage drop across the diode, then current through the diode. Is it clear, sir? Is it clear? This we have bypass on the tabulation exam. No need to bypass. So by seeing the circuit diagram itself, it clearly gives the indication that we need to take two readings by adjusting this input voltage. I hope many of them got reading for the forward bias. Okay. So this is the, see, in few experiments alone, we will give some input voltages. Why here the input voltages are given means, if you take some rapid readings, you may not get the same curve. Okay, wow. So the idea is up to this cut-in voltage, my readings are too narrow. So beyond that, I need little reading. In the bend, I need some readings. And to draw this straight line, you may require very minimal points. Okay, wow. By considering the shape of the waveform, we gave few readings by default. I hope you people are having this reading in your hand. Am I correct? எல்லாத்துக்கும் இந்த reading இருக்கா sir? Is it you people having this reading in your hand? Hello? If not, please take a screenshot of this one. I will help you to how to get this forward voltage by giving proper input voltage. Okay. Now what I am going to do, simply we are going to the simulation window. There we are going to create one annotation. So this annotation is going to help to record our readings. Okay. Serial number followed by voltage in volt, voltage in volt, then voltage drop across the diode, forward voltage in volt. Let me consider this in volt. Then current through the diode. Okay. So I have in milliampere. Okay. So this is the problem we are going to see step by step. First reading, can anyone recollect and tell me what is your first reading we need to take? Serial number 1. What is my input forward voltage given in the experiment? 0 volt. Am I correct? 0 volt. So how to start simulate this? Can anyone tell me how to start simulate this? I need to click what? This play button. Am I clear, sir? I need to click this play button. Okay. So first reading, I need to set it to my forward bias voltage as a 0. So forward bias voltage 0 abdina. So I need to change my input voltage as a 0 volt. So if I give input voltage as a 0, the voltage across the diode is 0. The current through the diode is how much? Can anyone tell me? How much it is? 0. So voltage drop across the diode is also 0. Current through the diode is also 0. Thereby, we are going to take the reading as my input voltage is 0. And forward bias voltage is also 0. And current through the diode is also 0. What our second reading we need to get? We need to get forward biasing voltage as 0.2 volt. How much we need to get? 0.2 volt. So what we are going to do to achieve 0.2 volt, I am going to increase my input voltage. Okay, ba? So input voltage if I gradually increase panna poren. Sorry. Wait a minute. Yes. So now we need to get the forward biasing voltage as a 0.2 volt. Let me adjust the input voltage gradually. Thereby, we will try to get how much I need to get 0.2 volt. Now 0.2 volt abindrathu, how much millivolt? Can anyone tell me? 0.2 volt. Hello?
200 millivolt.
200 millivolt. Very good. So let me adjust. Please observe this voltage drop across the diode alone. We are going to adjust this up to 200 millivolt. So 100 adukku vandirukku. Again I am going to click and increase the voltage. Yes. How much we got it? 200 volt. So please observe what is the input voltage we have given? 200 millivolt. Voltage drop across the diode? 200 millivolt. What is the current through the diode? 23.408 picoampere. Okay. So let me record this reading in our tabulation. Okay. So let me take the second reading as the input is 0.2 volt. The voltage drop across the diode is 0.2. Then the forward current is 23.408 pico. Picoampere. Third reading we need to get, sir. It is how much we need to get? 0.4. Okay. Let me adjust this input power supply gradually to achieve the voltage drop across the diode as 0.4 volt. Is it close to 0.4 volt, sir? Is it close to 0.4 volt? Am I clear? Hello? Yes. So, thereby I can record my third reading. Thereby I can record my third reading as what? Third reading as my input voltage is 400 millivolt, which is nothing but 0.4 volt. The voltage drop across the diode is 0.4 volt. Current to diode is 51.961 nanoampere. Yes. Now fourth reading, this fourth reading we need to get 0.6. 0.6. So 0.6, let me further adjust my input voltage. Do remember, we are adjusting the input voltage such a way that the voltage drop across the diode is our required value. Okay. Yes. Let me adjust to get 0.6 volt. Shall I stop here? Shall I stop here? It's approximately point. How much it is? 0.6 volt. Okay. Yes. Please tell me. What is the input voltage I need to feed? Anyone tell me? What is the input voltage? It's in millivolt. Please convert into volt. How we will convert into volt? Hello? Divided by 1000. இது எவ்வளவு கண்ணா வரும்? Hello? Hello? Kana, what is my input voltage? Can anyone tell me? 0.72 is the input voltage. So voltage drop across the diode? 0.6. What's the current to the diode? Current to the diode? 119.79 microampere. Okay. Yes. What's the second reading we need to get? What's the next reading? Sorry. 0.65. Again adjust this to achieve 0.65 voltage drop across the diode. 0.65 is nothing but 650 millivolt. Am I correct, sir? How much we need to get? 650.
1.5 volts, sir.
Very good. Who got the answer?
Yokesh.
Yokesh, very good. I hope you people are doing in the other side. Am I correct? யாருக்கா டவுட் இருந்தா கேள்றக்கனா டைம் வேஸ்ட் பண்ணக்கூடாது. The input voltage is 1.5 volt. Then voltage across diode is 0.65. Current to diode 849.1 microampere. Okay. What's the next reading we need to take? 0.67. Okay. 0.67 we need to get. Okay. Can anyone tell me what you are getting for the 0.67? Is it 2.54 volt you are getting? Hello? Approximately to this.
2.45, sir.
Okay, okay. I am getting 2.45. The current value 0.6. The voltage across the diode is 0.67. Now, current of the diode is 1.78 milliampere. Yes. Next reading. What's the next reading? 6.69 volt. 0.69 volt. Let me adjust further to get 0.69. Yes. How much you are getting, sir, to get 0.69? Can anyone tell me how much you are getting to get 0.69?
4.55 volts, sir.
4.6, 4.6 or 4.5. So this is 0.69. Can anyone tell me the slight approach to condition? What it is? Particular condition attend to follow. In this further work, it will pass one thing.
Sir, audio is not clear.
You get our attend voltage. Let's see how you got the reading up to this. If I increase little further, please observe our second reading is exactly given as 0.7. Okay, so 0.7. Now you closely observe. See, you can observe from this reading, my current is gradually increases from the pico, nano, micro. Now it attained milliampere. Okay. Now you observe, if I increase the voltage further as 0.7 volt, 0.7 volt is nothing but 700 millivolt. See, there is a huge current flow. It is around 5.7994 milliampere. Okay, please round off to 2-digit value. And you round off and tell me the value. 2-digit round off is
0.58.
no, milliampere is not milliampere. 5.799. Shall I make it as 5.8 number? 5.8 milliampere. Or else, if you round off for the 3-digit, 5.799 milliampere is the exact round off for 3-digit accuracy. 10. Second, the next reading, and you want to I need to take the voltage for 0.71. 0.71. Let me increase the voltage. 0.71 is nothing but 710 millivolt. Am I correct, sir? Yes. How much you are getting from your side? How much you are getting for 0.7?
9.10, sir.
9. You should not spell it as 10. 9.10. Am I correct? Am I correct? Yes. Then what's the current to the diode at this point? 8.3889.
8.38.
If I round off it, it is 8.39 milliampere. The next reading I need to get. Anyone unmute and tell what the next further voltage we need to get? Quick. Hello?
Sir, audio is not clear.
Audience, now, whether it is
Now,
clear
okay,
now?
sir.
Is it clear now?
Yes, sir.
Yes. What about the next reading? What about the next reading? What is the voltage drop across the diode I need to achieve now? I need to get
0.72.
72. So that nothing but 720 millivolt. Am I correct, sir? See, I am unable to increase further. What I need to do, sir? What I need to do? See, if I click further, I am unable to increase Further, what I need to do? I need to click
Into
this into 10. So into 10, again go back, then come step by step. Okay. So now we are going to get what? What is the reading we need to catch? We need to catch, okay, 7.2 we need to get. Yes. Shall we stick with this? Yes, we will stick with this. What is the input voltage? 13.0. 13.0. What's the voltage of across the diode? 0.72. Then current to the diode. Current to the diode is 12.28 milliampere. Okay. What the next reading we need to pick up? Hello? 720, then we need to get 730. Yes. What is the input voltage? What is the input voltage?
19.
19 volt. Okay. What is the voltage of across the diode? 0.70. What is the current to the diode? 18.72
70.
milliampere. Okay. What about the next reading? What about the next reading? Should be 740. Yes, 740. So 740, the corresponding input is 7.5. It is 0.74. And current to the diode is 26.76 milliampere. Yes. Then further, it increases up to 75.75. Yes. For the 0.75, I'm giving the voltages 40 volt, 0.75, and current to the diode for the corresponding input voltages. Yes. The next reading should be 760 millivolt. Yes. For 760 millivolt, what is the input voltage? 58.5.
58.5.
Yes, yes, very good. What is the current to the diode? 57.74 milliampere. Last. I think this is the last reading. Am I correct? Yes. So you can conclude with this. This is your reading. This is your tabulated reading. So whenever you do the experiment, please follow the same procedure. Okay. What is the advantage if you are taking readings here? Any advantage, Kanna? What is the advantage if you store your readings here? Hello? 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 இங்க நம்ம டைப் பண்ணி வச்ச என்ன அட்வான்டேஜ்? நம்ம சிமுலேஷன் முடிச்சிட்டு அப்புறம் ரீடிங் இங்க இருந்து காப்பி பண்ணிக்கலாம். Am I correct? Yes. Now I will tell you one thing. So while plotting the graph, so let me show the graph to you people. How you will start plot the graph. So you need to get the original graph sheet. Okay. So in that we have shown only, see, on a graph sheet இப்படி இருக்கும் ஃபுல்லா கரெக்டா? இதுல we have shown only this quadrant. Is it clear, dear students? இந்த graph sheetல first quadrant மட்டும் காட்டியிருக்கோம். ஓகேவா? In the first quadrant you need to take x-axis and y-axis 1 centimeter and 1 centimeter க்கு என்ன voltage and current values we fix show. Okay. So you need to draw a line like this. Then x-axis your forward voltage in volt, y-axis is your forward current in milliampere. Okay, wow. Then this is your origin. From the origin, take the scaling as 0.1, 0.2 steps of 0.1 to take the x-axis readings. Okay, then y-axis 10, 20, 30, 40 millivolt. Okay, it's not mandatory to keep the scale. We are giving one example how this. Okay, so that means your scale for one x-axis 1 centimeter is equal to 0.1 volt, 0.1, 0.2, 0.3. In y-axis 1 centimeter is equal to 10 milliampere. Okay, so then you substitute the readings step by step. Then you put the title also. Then you substitute the readings, first reading, second reading, third reading, and so on. So like this, you will get the number of coordinates. Then you join your coordinates. This is your A characteristics. Okay, then you need to mark your cutting voltage. You need to mark your cutting voltage. தெரியுதா இங்க மார்க் பண்ணிருக்கிறது தெரியுதா சார்? Is it clear? எப்படி கிராஃப் plot பண்ண எல்லாத்துக்கும் தெரியுதா? So now you people may have little confusion in your reading that, sir, here I am having many fraction values. What can I do? Very simple. Whenever you record your readings, in this column, you need to type only the numerical values. So நம்ம இப்ப என்ன பண்ணலாம்னா, we will remove this millivolt. The m என்றதை நம்ம remove பண்ணிக்கலாம். Because the millivolt is already mentioned in the tabulation top. This helps me to convert this pico ampere into milliampere. பண்ணோம்னா என்ன வரும்? I need to put so many zeros before the picofarad. So simply you consider this reading as 0. The name of ampere என்ன consider as 0. என்ன பண்ணலாம்? மைக்ரோ ஆம்பியர் மில்லியம் பார்த்தோம்னா ஒரு 3 டிஜிட் இந்த பக்கம் போகணும். தட் மீன்ஸ் என்ன வரும்? 0.0117 மில்லி ஆம்பியர். இது என்ன ரீடிங் வரும்? 0.849 மில்லி ஆம்பியர். How do you see the reading looks nice? Am I clear, sir? Am I clear? Hello? இந்த readings யூஸ் பண்ணி நம்மளால graph plot பண்ண முடியுமா? So it's very simple. In the top tabular column itself, in the top row itself, we have mentioned the unit for the particular quantity. Therefore, while you note down the reading, don't mark any units in that particular column. Okay? Is it clear up to this? Shall we proceed to the reverse biasing? Any doubts so far? Any doubts so far? Hello? I hope no doubt from your side. Yarka doubt irka? I will do one thing. See, I am going to delete this reference probe. Okay, I am going to delete this reference probe. Then I am going to start do the simulation for the same input voltage 58.5. What is the voltage drop across the diode? It is 0.76. Is it any change with our previous reading, sir? Is there any change? Is change irka? No. Appa enna meaning? So if you are measuring the voltage across the particular device with respect to the reference terminal 0, I no need to put the reference probe as an additional one. Why? By default, this voltmeter takes the reference as a ground. Is it clear, sir? Is it clear up to this? Is it clear up to this? Yes. Okay. Now what we are going to do? We are going to do the reverse biasing. Can anyone tell me what I have to do for the reverse biasing? Any idea from your side? Reverse biasing ki nam enna pananum? What are the modification we need to do in the circuit diagram? Hello? எதுல சேஞ்ச் பண்ணணும்? ஆனோட் கேத்தோட்? டயோட் அப்படியே ரிவர்ஸ் பண்ணி வைக்கலாமா? Shall I connect it like this? Why? பேட்டரி ரிமூவ் பண்ணா மட்டும்தான் ரிவர்ஸ் பயாசிங் ஆகுமா? டயோட ரிவர்ஸ் பண்ணா ரிவர்ஸ் ஆகாதா? Please observe. This is my anode terminal. This is my cathode terminal. Where I have connected anode, I have connected to the negative terminal. Cathode connected to the positive terminal. Whether this will become a reverse biasing or not. Hello? Hello? Can I the reverse bias act aguma agada? Any idea?
Yes, sir.
Hello? It will become reverse biasing, no? So there is only one small change we are going to carry out in the reverse bias characteristics. Then we are going, this is the characteristics what we are going to get it. It's very simple, very simple. While I am not going to cross this border. In the border cross panamna, you will get the rapid increase in the current. But device ennagum normal PN junction diode la beyond breakdown voltage kapra voltage kudutha diode ennagum it will get damaged. Am I correct? Am I correct? Therefore, we are not going to increase the voltage beyond this. So I will get a nice graph like this. Current slight increase agum, then it will maintain as a constant one. So constant or current varapodi. So let me observe these characteristics. Before that, this is our data sheet. This is our data sheet of the PN junction diode. In that, we are going to set one thing in our simulation software that we are going to set our reverse saturation current. Now, the subject we have studied as IS. Am I correct, sir? IS na enadhu? What is IS? What is IS? IS saturation current. Okay, wow. So in the data sheet lab, this is the data sheet belongs to the diode name called 1N4 not 7. This is the model of your diode. Please make a note of this. 1N407 diode. Okay. What is the forward current? Hello? Remaining, this is the forward voltage drop. Temperature operate but while doing reverse characteristics, we are going to give this input parameter to our software. Where we are going to give means, I will show you, this is our multisim window. In that, we need to substitute the reverse saturation current, what is given in our data sheet. I will help you to do this thing, don't worry. Now with this idea, we will get into the reverse characteristics experiment. Before that, please take down the reading, what you need to set across your diode. Reading se konja screenshot edutukalama. Dear students, if you took a screenshot, please say yes. Thereby we will proceed. Hello? Shall we proceed? Can I allow the screenshot edukacha in the reading? Yes, sir. Yes, thank you. Okay. So now what I am going to do, I can make a modification in the same circuit, okay? But let me take a new circuit to you people, thereby you will learn. Let me take one circuit. In class, okay? Successfully saved. Okay, let me take a new file. Yes, I am getting new file. While you do the experiment, do it in the same sheet. Same sheet, you can take your readings. Experiment number 1. Yes. What things I need to take? The first one, DC voltage source, followed by what? Resistor, then diode, then what else we need? Voltage probe, current probe, then ground. That's all. Here what we are going to do, we are going to rotate this. Why I am going to rotate this? I am going to get this reverse bias. Okay, wow. கொஞ்சம் குயிக்கா கனெக்ஷன் கொடுங்க பார்க்கலாம் from your side also. Make it fast. கொஞ்சம் ஸ்பீட் அப் பண்ணலாமா? Yes. Get the current probe, keep it here. Get the voltage probe, keep it here. This is one kind of reverse bias diagram. Another one, I can keep the diode as such. I can reverse what? I can reverse what? Hello? Diode, let me keep it in the same orientation. இப்படியே வச்சுக்கலாம். But எதை reverse பண்ணணும்? எதை reverse? You need to rotate your source. Source on reverse connect பண்ணி connection கொடுக்கலாம். Okay. So let me take this circuit diagram and we will do the simulation. Okay. What is the setting we need to keep? I told click the diode, then click the setting icon. If you make double click, you will get this window. You will see. I'm going to double click over the diode. I'm getting the setting. What I need to set over here? Can anyone help me? What is the reverse saturation current I need to set, sir? 5 microampere. அப்படிங்க எவ்வளவு செட் பண்ணணும்? 5 exponential of minus 6 or plus 6? Hello? Sorry, plus 6. Hello?
Yes, sir.
கணக்கு மைக்ரோ ஆம்பியர்ல என்ன செட் பண்ணணும்? 5 மைக்ரோ ஆம்பியர் எப்படி செட் பண்றது? பை டிஃபால்ட் என்ன இருக்கு சார்? பை டிஃபால்ட் என்ன இருக்கு? பை டிஃபால்ட் இருக்கு. ஹலோ? பை டிஃபால்ட் எவ்வளவு இருக்குது? 1 sorry. By default it is 1 exponential of minus 14. I need to change it into 5 microampere. எவ்வளவு சார் செட் பண்ணணும்? 5 exponential of minus 6. Is it clear, dear students? Is it the setting is clear to everyone? Hello? Please see, you make a double click over the diode, then you will get the setting. You will find the saturation current setting in the right hand side. There you need to set as a 5 microampere. If you did so, please say yes. Thereby we will start do the experiment. Make it fast. Please make it fast. Is it clear, sir? Hello? Can எல்லாத்துக்கும் இந்த செட்டிங் வந்துருச்சா? Any doubt in this? Any doubt in this? No. Can I proceed பண்ணலாமா? ஏதாவது டவுட் இருக்கான்னு கேக்குறேன். லோகேஷ், தனுஷ், ஸ்ரீஹரி வரைஞ்சிட்டு இருக்கமா தூங்கிட்டு இருக்கமா? ஹலோ? Okay. Can I get in the experiment முடிஞ்சதுக்கு அப்புறம் I will ask you people to present your screen. Okay, why you need to present your screen, be ready. Okay. Yes. Now after finishing our reverse saturation current setting, as usual, let me take the annotation. What are things I need to take here? Serial number followed by voltage in volt, then my reverse voltage across the diode, then a reverse current. Here, reverse current we are going to take microampere. It is in microampere. எந்த கரண்ட் அதிகமா இருக்கும்? ஃபார்வர்ட் கரண்ட் அதிகமா இருக்கும், ரிவர்ஸ் கரண்ட் அதிகமா இருக்குமா டயோட்ல? forward current magnitude தான் அதிகமா இருக்கும். ஓகேவா? Yes. Okay, come back here. So please help me by referring your circuit diagram. How I can start do the simulation? So you want to label this, how you can alter this labeling? How you can alter this labeling? Can anyone tell me? Simply click over this, then change the name as what? IR. Okay. Simply click over this, then change the name as VR. Yes. Practice. நம்ம என்ன மெஷர் பண்றோம்ன்றது உங்களுக்கு இன்னும் கிளாரிட்டியா தெரியும். Okay. So start simulate. Give the input voltage as a 0 volt. Give the input voltage as a 0 volt and take the reading. So what is the reading I need to record? What's the reading I need to record? What's the input voltage, sir? What's the input voltage? 0. What's the reverse bias voltage across the diode? It's also 0. What's the current in the diode? It's also 0. Yes. What is the next reading? Can anyone tell me? What is the next reading? What should be the voltage drop across the diode I need to set? Please tell me. 25. Hello. Are you having this reading in your hand? Can the reading screenshot எடுத்துக்கிங்களா? அப்ப எவ்வளவு voltage வரணும்? 25 millivolt. That is nothing but what? 0.025 volt. Am I correct? Okay. So 25 millivolt we are going to get it. Now I am going to gradually increase the input voltage. So sorry, 25 millivolt is hello. 25 millivolt கொண்டு வரலாம். ஓகேவா? Let me adjust to 25 millivolt. $26.7 வருது. இது let me adjust through this. 24 point something. We need a 25. So let me type 28 millivolt. It's 28.5. It's 28 point. Yes. So what's our input voltage? Can anyone tell me? Input voltage? Input voltage is 28.1 millivolt. So volt எழுதுனா எப்படி எழுதுனா? 0.0281 volt. Voltage up across the diode is 25 millivolt. So that is 0.025. Then the current through the diode, straight away I am getting 3.098. Okay, wow. So let me that's 3.1 microampere. Okay. The next voltage drop we need to get. What is the next voltage drop we need to get? 50 millivolt. Am I correct? Okay. Let me increase the voltage. Yes. 50.2. So let me adjust here. 40.3, 40.5, 40. If you want to get exact fraction value, manually also you can feed the voltage, input voltage. Okay, I am going to feed that's a 54.3. Yes. What's the input voltage I need to type here? What is the input voltage I need to type here? Yes, 54.3 millivolt is nothing but 0.054 millivolt, 3 volt. Then voltage drop across the diode is 50.02. Then current to the diode is 4.277. Likewise, if you increase the voltage gradually, you will get the corresponding current. Okay. I'm not going to take all the readings. Let me skip few things and straight away I will come to 1, 5, 10, 15. Okay, so we will try to get these voltages. I'm going to increase the voltage gradually to get 1, 1, adukadutha enna varanum 5, 10. Okay, so I'm going to increase the voltage. Yes, okay, let me increase the voltages. Yes, for 1 volt, for 1 volt, what is the voltage drop across the diode, sir? Sir, inge da 1 volt varnuma. So let me increase little. Shall we take it as a 1 volt? Shall we take it as the 1 volt? Yes. What is the current through the, what is the current through the diode? What is the current through the diode? 5
5
microampere. Let me increase the voltage further. Let me increase the voltage to around 5 volt. What is the current through the diode? Again it is 5 microampere. Again I am going to increase the voltage further. There is no change in the current. Why is that? Why there is no change in the current over here? Please observe your model graph. Please observe your model graph. Beyond some value, my current values constant. This is your reverse saturation current. Am I clear? Am I clear? So here what you need to do, take the reading up to the given value. So what is the voltage value given? In our case, it is given up to 50 volt. Okay, let me take the last reading. Let me take the last reading and show it to you. The voltage drop across the diode, 50 volt. Let me attain. Yes, so approximately 50 volt. What is the current through the diode, sir? What is the current through the diode? What is the current through the diode? It is 5 microampere. Okay, I hope this forward bias and reverse bias characteristics is understandable to you. Here only one small change. Whenever you plot the graph, so graph plot பண்ணி நீ draw பண்ற அப்படின்னா forward biasing draw பண்ணும்போது, listen, forward biasing draw பண்ணும்போது இந்த scale, இந்த current value you need to keep it in milliampere. Reverse biasல இது என்ன scale ஆ வைக்கணும்? You need to keep it as a microampere. Is it clear, dear students? இங்க வந்து 0.1, 0.2 scale எடுக்கலாம். ஓகேவா? அப்ப இதுக்கு என்ன scale எடுக்கிறது? Please observe your voltage drop across the diode. இது எவ்வளவு சார் இருக்கு? மேக்ஸிமம் எவ்வளவு இருக்குது? 50 volt இருக்குது. Is it clear? 50 volt இருக்கு. So அப்ப இந்த ஸ்கேலிங்ல எவ்வளவு ஸ்கேல்ஸ் வச்சா 50 மேக்ஸிமம் ரீச் ஆகும் பாரு. ஓகேவா? So say example, இது 50, இது 0ல இருக்கு. அப்ப எவ்வளவு ஸ்கேல்? 1, 2, 3, 4, 5, 6, 7, 8. 50 divided by 8 எவ்வளவு சார் வரும்? Simply you can keep 5 volt. Is it clear, sir? 5, 10, 15, அதுக்கப்புறம் என்ன வைக்கலாம்? 20, 30, 40, 45, 50. வைக்கலாமா? Yes. So you can draw it in the separate graph sheets. தனித்தனி graph sheet வச்சு draw பண்ணலாம், இல்ல single graph sheetலயே divide பண்ணி draw பண்ணலாம். Which one is familiar to you? You can do it, no issue. Okay வா? So அப்ப single graph sheet வரைஞ்சா forward characteristics வச்சுக்கோ, இன்னொரு separate graph sheet வச்சினா reverse characteristics வச்சுக்கலாம். Any doubt up to this? யாருக்கா doubt இருக்கா? So this is, yes, tell me.
Sir, diode la changes கொடுத்தீங்களா sir? Saturation current la value.
Yes.
அது வந்து micro -6.
ஆமா. Is it clear?
ஆனா சார் நான் பண்ணும்போது அங்க கரண்ட்ல வந்து 5 பாயிண்ட்னு வரல சார், 1 பாயிண்ட்ல வருது சார் மைக்ரோல.
அப்ப நீங்க ரிவர்ஸ் சேச்சுரேஷன் செட் பண்ணிருக்க மாட்டீங்க.
ஓகேங்க.
சேச்சுரேஷன் கரண்ட் சேஞ்ச் பண்ணு. ஓகே
ஓகேங்க சார்.
okay yes, I hope I am clear up to this. Then this is only part of our first experiment. The second part is Zener diode. Zener diode. So Zener diode again I need to carry out two things. One is the forward biasing, another one is the reverse biasing. Okay. So let me show the circuit diagram of the forward biasing. Is any change from your forward biasing of PN junction diode and this one? Without change
Only the diode changes.
only the diode you need to change. Okay, so please take a screenshot of this one. This is a circuit diagram. Using this circuit diagram you are going to take these readings. I think these readings are very much similar to what இது எதுக்கு சிமிலரா இருக்கு? ஆல்ரெடி உங்களுக்கு கொடுத்த ரீடிங் ஃபார்வர்ட் பயாஸ் கொடுத்த மாதிரி இருக்கு. Is it clear? Yes. Let me show only one or two readings. Now, see, let me take one new form and I will draw both forward and reverse characteristics. Okay. Yes. Yes. So experiment number 1B. Can you do one thing? Experiment number எல்லா எக்ஸ்பெரிமெண்ட்ஸையும் இந்த ஒரே ஷீட்ல நீ டிராக் பண்ணி வரைய முடியும். ஓகேவா? ஓகேவா? நீ ஒரே இதுல வரைஞ்சு ஸ்கிரீன்ஷாட் அனுப்புனாலே போதும். எல்ஸ் பிஎன் ஜங்ஷன் ஃபார்வர்ட் அண்ட் ரிவர்ஸ் வரைஞ்சு. ஓகேவா? தட் இஸ் எக்ஸ்பெரிமெண்ட் நம்பர் 1A ன்னு ஒன்று கொடுப்போம். 1A ல ஃபார்வர்ட் ரிவர்ஸ் ஆஃப் பிஎன் ஜங்ஷன். 1B ல Zener diode forward and reverse bias. Okay. So this is my. Kana solunga, any doubt? One A. Suggest sir. Suggest sir. 1A, 1A, 1B ஒரு sheet. Okay வா? அதான் 1A ல ஃபார்வர்ட் ரிவர்ஸ் செப்பரேட்டா ஒரு ஷீட்ல. ஓகேவா? ஒரு ஷீட்ல. ஓகே. 1B செப்பரேட்டா இன்னொரு இதுல. ஓகே. Okay, let me take a Zener diode and then ground and then voltmeter and then ammeter. Yes. How to connect this? How to connect this? I need to rotate this. So கொஞ்சம் குயிக்கா எல்லாரும் இந்த காம்பனன்ட்ஸ் எல்லாம் எடுத்துட்டீங்களா? Taking very less time to draw the circuits. Within a fraction of seconds, you can draw the circuit diagram. That's all. Diagram draw பண்ணி முடிச்சாச்சு. So forward biasing என்ன பண்ணணும்? I need to start simulate. Then gradually I need to increase the voltage. Then I need to measure the voltage drop across the diode, the corresponding input voltage and the current through the diode. இதுல யாருக்கா டவுட் இருக்கா? இதுல ரீடிங் எடுக்கிறதுக்கு? This is very much similar to your PN junction diode forward biasing. Okay, but reverse biasing matter we need to do small changes that I will show you. This is where reverse diode characteristics. The circuit diagram is very much similar to your PN junction diode. Here, in the reverse bias characteristics, we will go beyond this breakdown voltage also. Any idea? Can anyone tell me why we are operating this one in this particular region? Why not PN junction diode? Can anyone tell me? ஏன் PN junction diode இந்த ரீஜன்ல ஒர்க் பண்ணல, இதை மட்டும் இதுல ஒர்க் பண்றோம்? Any idea? Any idea? Hello? Hello? ஆனா பிஎன் ஜங்ஷன் இந்த ரீஜன்ல ஆப்ரேட் பண்ணல, ஜீனர் டயோட ஒர்க் பண்றோம். வை?
அது ஸ்பெசிஃபிக்கா இது செய்யறது டிசைன் பண்ணிருக்கோம்.
Zener diode is specially designed to operate in reverse bias only. Thereby, it will withstand for the reverse bias voltage, and also the reverse bias voltages are not so much as your PN junction diode. Please observe here in reverse bias also the current through the diode is in milliampere. But in case of normal PN junction diode, it is microampere. It doesn't conduct. That means microampere na, it is very, very low current. Okay. So attain this characteristics, we are going to take number of readings. Before that, you people know the Zener diodes are supplied with the different voltage ratings. Am I correct? நம்ம இன்னைக்கு டேட்டா ஷீட்ல பார்த்தோம்ல, 5.1, 8.2, 3.3 இது மாதிரிலாம் ஒரு வோல்டேஜ் இருக்கு. Am I correct? This is called VZ, Zener voltage, Zener breakdown voltage. See, if in the particular voltages, we need to set in our virtual tool also. How to set? Please observe, this is the menu. You will find it as a V breakdown. In our experiment, we are going to keep this voltage as a 5 volt. Okay? Shall we choose this Zener voltage and start with the experiment? Any doubt in this, dear students? Any doubt in this? Karka doubt rika? I will show you, don't worry, where to set this one. Okay. Please take down this voltage level alone. So here they have given input voltages. Input voltages kuduthirukanga. We are going to set this input voltage and we are going to observe what is the corresponding reverse voltage across the Zener diode and also the current through the diode. Shall we proceed? Have you taken the screenshot of this one? Please, if you took, please say yes. Thereby we will continue the experiment. Can I edit the screenshot? Yes. Yes. Now I am going to see. This is our existing circuit diagram. If you want to draw new diagram, please see here. You will find one option, the scrolling option. Am I clear? So either down you can draw the new circuit diagram. So half of the portion is the forward bias. The second half we are going to draw the reverse bias. Okay. So reverse bias. Yes. So reverse bias we are going to draw again. DC voltage source, ground, Zener diode, voltmeter probe, voltage probe, current probe. Then the resistor. Okay. Yes. So let me take all the components, proper place. Yes. Please help me. Please say stop if my orientation is right. Is it correct? Shall I stop here? Shall I stop here? Yes. Yes. That's all. Then what? Let me take the annotation. Okay. So serial number, then serial number, input voltage, B input voltage, then reverse voltage volt, then reverse current in milliampere. Tell me what is our input voltage? Input voltage I need to keep 0. Okay, let's start the simulation. Yes. Let me keep the input voltage as 0. What is the corresponding ammeter and voltmeter readings? 0, 0, 0, 0. So you people are trying the same thing in your side also? எல்லாரும் drop பண்ணிருக்கீங்களா? Sure. Yes. What is the second input voltage we need to keep, sir? Oh, before that, I forgot to show one thing. Stop simulation. Double click over the Zener diode. Here you will find the Zener breakdown as how much? Zener breakdown as how much? 5 volt. Okay, 5 volt. Yes. By default, it is 5 volt. If you want to change, you can change. Now, what is the Zener breakdown voltage? Can anyone tell me by seeing this diagram? What is the Zener breakdown voltage?
8.2.
8.2. So how to alter this? Double click over this, then you will find the virtual window. There you click the voltage as a 5. Yes, come back. Now, what is the second reading I need to give is as an input? It is 1 volt. So start simulation. Now it is very, very simple. Since you are going to give the input voltage alone, simply type the value 1 volt. What is the corresponding forward voltage and the current through the Zener diode? Can anyone tell me? Can anyone tell me for 1 volt, what is the voltage of the Zener diode? It is 999.8 millivolt. It is nothing but what? 1 volt. Am I clear, sir? Yes. Current out of the concept 199.96 nano ampere. That is equal to 0. Okay. Third reading. How much I need to give? I need to give the third reading as a 2 volt. 2 volt. What is the corresponding voltage drop across the diode, sir? This is also the 1.996 approximately. It's also 2. Current to the diode is 0. Okay. Fourth reading. Fourth reading, let me increase the voltage as 3 volt. Check the reading. How much? It is also 3. It's also approximately 3. Current microampere, consider it as 0. Yes. Then now let me take the input voltage as 3. Actually, they didn't give. They gave 2, no? Okay, no problem. Let me give 4 volt immediately. How much I am getting? Again, same thing. Again, same. So, blah, 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 some other reading. Okay. Now, let me give the input voltage as 8 volt. Please observe the change. What is happening now? Can anyone tell me? What happened to my system now? Is it increased beyond 5 volt? Hello, sir? Hello? No. No. Approximately 5. Check the current. Check the current. It getting increases. Am I correct? Am I correct? Yes. What is the next voltage, input voltage I need to give? 8 volt. Then I am going to give 12 volt. Is there any change across the diode? No. No, there is no voltage changes across the diode. But current through the diode getting rapidly increases. Likewise, I need to give the input voltage up to how much? What is the last reading they gave? 60 volt. It's a slight increase in voltage, 5 to 5.02. 5 to 5.02. 3 sir? 5 to 5.02. Consider this as a 5. The last reading what you are going to take is what? 5.02. புரியுதா? புரியுதா? So likewise you are going to get the reverse characteristics also. Any doubt in this? Any doubt in this? Doubt? I will tell you only one new setting. What you have to do it for Zener diode. Double click over the Zener diode and set the breakdown voltage. Okay. This is the time to see your outputs. Okay. ரெண்டு கிளாஸ்லயும் ஒரு ரெண்டு பேர் உங்களோட அவுட்புட்டை ஷேர் பண்ணி பார்க்கலாம். நீ என்ன ட்ரை பண்ணியிருக்க, ஏதாவது டவுட்ஸ் இருக்குதா கொஞ்சம் குயிக்கா? We are going to see next experiment. Before that time, let me check your outputs. கொஞ்சம் குயிக்கா காட்டலாமே. யார் கம்ப்ளீட் பண்ணிருக்க? Please share your screen. எனக்கு PN junction diode காட்டினா கூட ஓகே தான். Zener diode you show it later. இல்ல Zener diode output காட்டுறீங்களா? Which one you are going to show? Hello? Haris 117. Ajita மிதுன் கிளம்பிட்டா கூப்பிட்ட உடனே. ஆனா குயிக் யார் முடிச்சிருக்கீங்க? ஹலோ கார்த்திகேயன் 222. காவ்யா ஆனா யாருமே டிராப் பண்ணலையா? ஹலோ ஹலோ சஜித் சார், am I audible sir? யாருமே ரெஸ்பான்ஸ் தரல. ஆனா நீ தரலன்னா நான் அப்படியே நான் அடுத்த எக்ஸ்பெரிமெண்ட் ப்ளீஸ் ஷேர் யுவர் ஸ்கிரீன். ராமகிருஷ்ணன்
எஸ் சார்.
டிரா பண்ணிருக்கியாடா கண்ணா?
பண்ணிருக்கேன் சார். இன்கம்ப்ளீட் ஆகுது சார். கம்ப்ளீட்
ஷேர் யுவர் ஸ்கிரீன்.
ஓகே சார்.
நோ சார் பண்ணல சார். கஸ்டமர் சார் ட்ரை பண்ண கஸ்டமர் விட்டுட்டேன் சார். போன ஒரு ரெண்டு பேரும் முன்னாடி அப்போ பண்ணல. ரெண்டு பேரும் டைம்ல பண்ணல. ஃப்ரீ டைம்ல பண்ணி பார்த்தேன் சார். ஹாலிடேஸ்ல.
சார் ஷேர் ஆதா சார்?
ஷேர் ஆயிடுச்சு கண்ணா. ப்ளீஸ் ஷோ யுவர். எஸ் வெரி குட். ரன் பண்ணுங்க, சிமுலேட் பண்ணுங்க. சிமுலேஷன் ரன் ஆயிட்டு இருக்கு. ஓகே. சேஞ்ச் தி இன்புட் வோல்டேஜ் as 50 volt 50. அண்ணா you can click there, you can type immediately 50 50. Okay, very good. You need to annotate. Okay Vakana, you need to title the project.
Yes sir.
Ramakrishnan, you need to title the project, then
okay.
You need to annotate. Kana anyone else? Yogesh யாராவது முடிச்சிருக்கீங்களா? Rijesh?
Yes sir, finish sir.
Share your screen. Kana இங்க A sectionல யார் பண்ணிருக்கீங்க? A section yes. Can I listen? Can I please save your work? இல்ல செகண்ட் டைம் நீ ஓபன் பண்ணும்போது சேவ் ஆயிருக்காது. Then you need to redraw once again. Okay. See, go to this top icon and click save. A section யார் முடிச்சிருக்கீங்க? நந்தகுமார், நரேஷ், ஹரிஷ், ஸ்ரீஹரி. Okay, can I you present? Yogesh, present your screen.
Yes sir.
Can I A section? யாருமே வரலையாடா? ஹலோ யார்ட்டுமே லேப்டாப் இல்லையா? ஸ்ரீஹரி. சரி, அப்ப நான் ஒன்று பண்றேன். நீங்க பேசுற வரைக்கும் நான் உங்க கிளாஸ் நான் மியூட் பண்ணிக்கிறேன். சரியா? ஆல் மியூட் ஆப்ஷன். ஓகே, நான் மியூட் பண்ணிக்கிறேன். நீங்க யார் வாய் திறந்து எனக்கு அவுட்புட் காட்டுறீங்களோ அது வரைக்கும் நான் அந்த கிளாஸ் எடுத்துட்டு இருக்கிறேன். சரியா? எஸ் சார். ஆ கண்ணா வெரி குட் வெரி குட். கொஞ்சம் ஜூம் பண்ணி காட்ட முடியுமா யோகேஷ்?
மேல இருக்குது டாப்ல
ஓகே.
இருக்குது சார்.
ஓகே வெரி குட்.
இது பிஎன் ஜங்ஷன் சார்.
PN
ஜீனர் டயோடு வந்து
show your circuits.
Let me show this Zener diode,
Yes,
sir.
yes. Sajid sir. Sajid sir. Okay, is it anyone facing the problem to draw the circuit? யாருக்கா difficulty இருக்கா? ஆனா நீங்க மொபைல் போன்ல வரையவே எதுல வரைஞ்சிருக்கடா யோகேஷ்?
Mobile, sir.
மொபைல்ல தான் டிரா பண்ணிருக்கான் பாரு. ரொம்ப அழகா சூப்பர்.
Sir, Zener diode reverse bias, sir.
Yes, very good.
Yes, sir.
Yes, you do one thing. Zoom
Yes,
it little. Yes. Give the input voltage as 40 volt and show your output.
Yes, sir. 1 second, sir.
Yes.
Yes, sir.
Yes. Good. Okay. Thank you very much.
Yes, sir. Thank you, sir.
Yes. Shall we proceed to the next exercise? Olama? Shall we proceed to the next experiment?
Yes, sir.
Yes. Sajid sir?
சொல்லுங்க சார்.
அங்க ஏ செக்ஷன்ல யாரும் காட்டல?
இல்ல சார், அங்க உங்களோட ஸ்கிரீன் மட்டும்தான் நீங்க இல்ல உங்களோட ஸ்கிரீன் மட்டும்தான் அங்க தெரியும்.
இல்ல are they facing?
சார் யாரும் காமிக்கல.
காட்டல. Could I please wait? I will come back B section. Okay. Okay. So next exercise, experiment number 2. Can anyone tell me what is our next experiment by referring your syllabus? Any idea? What is our next experiment? Hello? Hello? Okay, take down your next experiment. Study of, yes sir. Wait a minute, sir. Sir, okay. Sir, screen present ஆயிருக்கு sir. Okay. Yes. Yes. Can I please take down your next experiment and also the date for the next experiment is 16/4/2021. Okay. Actually, I supposed to tell few more things to you people. You people are not responding. Thereby, let me finish the experiment. Remaining things we will discuss tomorrow. Okay. Experiment number 2. Study of off wave and full wave rectifier circuits. Okay. So half wave and full wave rectifier circuits. In theory class, we have finished the half wave rectifier. Full wave rectifier is still pending. Anyhow, you have few questions over here. What are the questions you can able to answer? Please answer. Else we will share you the answer. Okay. Before that, the aim of the experiment to study half wave and full wave rectifier circuits. The components required in the multisim as usual. We are going to use different power supplies. Since it is a rectifier, I need a AC supply. Then I need diode, resistor, current probe, and voltage probe. Can anyone tell me? In our theory portion, we have studied one more component in between this. Can anyone tell me what is that?
Transformer.
No, transformer. Am I clear, dear students? Transformer. We skipped transformer. Why? I will tell you. Okay. We are going to do the analysis in the step down portion of your transformer. Thereby, the step down voltage. Say example, this is my 230 volt. Then I am step downing the voltage to 5 volt. Say example, abdina. I am straight away going to take the 5 volt source. Okay, that is the idea behind this. Why we are not using the transformer. Okay, that's all. Okay, without making much discussion, I will do one thing. I will take one new file, and keep the experiment name as experiment number 2. Okay. So, what are the components we need to implement the half wave rectifier? Just now we have seen. Can anyone recollect and tell me what are the things I need to fetch it from here? First one is what? First one, what? AC
power supply.
voltage source. Yes. Then, what else we need? Diode. Then, லாரி யாருக்குடா வருது? Hello? I made it mute, sir. Yes. Yes. Yes, can I get This is my AC source. This diode is going to rectify. The rectified output I need to give it to one load. Am I clear, sir? என்ன load நம்ம generally use பண்ணுவோம்? Resistive load, capacitive load or inductive load?
Resistor load.
Resistive load. Okay. This is my diode. So, okay, how to connect this? Please help me. How to connect this? Please help me. How to connect this one? Hello? Hello? Diode to positive. Here it is not a positive. Let me keep it as a phase neutral. Okay, phase to anode terminal of the diode. And then cathode to resistive load. Then resistive load to another end of the source. Is it my off-wave circuit diagram is over? Is it my off-wave circuit diagram is over? Okay, let me take the current probe and voltage probe. Yes. So here my input voltage is the AC supply. Output voltage is what? Rectified DC output. Am I correct? Am I correct? So before that, what are the parameters I need to measure from this? Let me see once. Listen, let me skip these theory questions. I will ask you later. Don't worry. So this is my circuit diagram. This is my circuit diagram. Here I need, this is my input voltage. This is my diode. This is my load. So what we are going to do means, we are going to give some input voltage. For the given input voltage, we are going to measure the load current as well as voltage drop across the resistor. What are the probes I need to connect over here? Enna probe connect pananum? Current probe and voltage probe. Shall we connect these two alone and we will check something? Check பண்ணி பார்க்கலாமா? இதுக்கு input voltage எப்படி இருக்கும்? Sinusoidal input. Output என்னவா இருக்கும்? Output என்னவா இருக்கும்? Any guess from your side? It's a only positive half cycle only we will rectify. Okay. Then what I need to take the readings of the experiments means, I need to take the load RMS value, then load DC voltage, then load DC current. Please observe one thing. Current பொறுத்தளவுக்கு ஒரே ஒரு quantity தான். Voltage பொறுத்தளவுக்கு எவ்வளவு quantity இருக்கு சார்? Two things. One is what? DC component, another one is the RMS value. Then we need to measure the output frequency in hertz. Enna measure பண்ணனும்? Output frequency in hertz. After finding these things, you need to calculate the ripple factor. Please take the screenshot of this one. Please take the screenshot of this one. Quick. Eduthacha? Yes. Now you tell me using voltage probe and current probe. Using voltage probe and current probe, what are all the quantities you need to measure? These are all the quantities. One is what? Load RMS value, then load DC voltage, then load DC current, then output frequency. Okay. Once you find these parameters, you can find the ripple factor. Okay. Come back to our simulation. How to measure the load current? Where I need to keep this probe? Shall I keep it here, sir? Shall I keep it here? Hello? Shall I keep it here?
Yes, sir.
Yes. How to measure the load voltage? Shall I keep it here? Is it anything missing in my circuit diagram? Are we specified the reference for the circuit diagram? Ground symbol is not connected. So simply press G, you will get ground symbol. Let me do one thing. Without making any change, I'm going to start the simulation. Are you getting any standstill reading? Is it possible to take this reading, sir? Reading எடுக்க முடியுமா? எடுக்க முடியல. Why? Since it is an alternating quantity, with respect to time, the value will keep on changing. Am I correct, sir? So for that, I need to do one small setting in the probe. Wait a minute. Let me click the voltmeter first. Here you are finding one thing. One is the called instantaneous value. The second one is the periodic. Can you see these two options? At present, what quantity we measured? Can anyone tell me? At present, what quantity we have measured, sir? Instantaneous value or periodic?
Instantaneous.
So instantaneous value, we are unable to capture the readings. So what I need to do? Please help me. What I need to do? Change the setting into periodic. See, simply I click it periodic. Immediately I am getting some value over here. Is it clear? Is it visible to you people? Can you spell what are the readings present over in your screen? First one. V peak to peak, VPP. Am I correct, sir?
Yes, sir.
What is the yes, what is the second reading? What is the third one? It is the DC voltage. DC voltage. Okay, average voltage. What about the fourth one? What about the fourth one?
Frequency.
Frequency. Let me make the same change for my, let me make same change for my ammeter too. Double click the ammeter, change instantaneous into periodic. Are you getting the values again? The periodic, are you getting the different values over here? Yes, yes. Is it clear? So, whenever you are doing AC analysis, if you want these readings, do remember one thing. Double click over the probe and change the setting into, by default, it will be instantaneous. Change the instantaneous value into periodic. Nothing wrong if you select both the things. If you select both the things and if you run the simulation, the instantaneous value will keep on change. But here and below, you will be getting the periodic outputs. Is it clear to everyone? Is it clear to everyone? Let me change the input voltage and check whether my periodic voltages are getting varies. Is it is getting alters? Is it getting alters?
Yes, sir.
It's very simple experiment. It's very simple experiment. Okay. So here the thing is you need to take only these readings. Okay? Only these 4 readings. From this you need to calculate your ripple factor. Okay. Now we will do one thing. Let me take few more procedures what we have discussed in detail. This is the thing. If you want to measure your input voltage, you can keep one more probe over here. Okay. So in the experiment, they have asked only the output voltages. So we didn't kept the input probe, but it is good practice that always we can measure the input voltage also. Okay. Yes. Then to take this VLDC and VRMS and ILDC and IRMS. These are all the 4 quantities we are going to note down. One of the things is not available in your table. Anyhow, we are going to take all the 4 readings. Here, they gave the input parameter as V peak or max is equal to 5 volt and the supply frequency is 50 hertz. Can anyone tell me by default what we got the voltage? By default, enna irundhuchu sir? If you by default enna irundhuchu? Yara solla mudiyuma? Idhula frequency ennava irukku by default? Frequency ennava irukku by default? 1 kilohertz irukku. Yes. Even I forgot what is the default input voltage. It is 1 volt. The default input voltage is 1 volt. The default supply frequency is 1 kilohertz. But in our experiment, they asked to change one thing. What is that? The input voltage is 5 volt and supply frequency is 50 hertz. How to alter this? Any idea? How to alter this? இது எப்படி சார் ஆல்டர் பண்ணலாம்? இந்த வோல்டேஜை நான் 5 வோல்ட்டா மாத்தணும். என்ன பண்ணணும்? எனி ஐடியா? இது எப்படி மாத்துறது? நான் டபுள் கிளிக் பண்ற எல்லாத்துக்கும் தெரியுதா? Can you see? I making double click. Here the thing is that here it is given as a V1. First of all, let me label it as a V in. V in name. Followed by I'm going to double click this. There I am going to set the input voltage V peak as 5. How to change the frequency and what is the value of the frequency I need to feed? 50 hertz. That's all. Thereby we gave the input voltage as 5 volt and the supply frequency as 50 hertz. Then we will start do the simulation. We can take the readings. Let me go through the contents little deep. Are we missed anything? No. So we changed it as the input voltage, and we gave the input voltage peak voltage as 5 volt, supply frequency as 50 hertz. Then after that, we are going to set the voltage probe to measure VLDC and VRMS. Okay. So அப்ப என்ன பண்றோம்? இந்த probeக்கு name என்ன கொடுக்க போறோம்? VLDC. In that, keep remember one thing. You need to select periodic. Can anyone tell me why we need to select periodic? Can anyone tell me why? Fixed our reading நமக்கு வேணும். Oscillate ஆகிற reading. By default, it will give instantaneous value. We need some that average value, RMS, some calculated values we need. Therefore, we are going to change the setting in all the probes. Then input voltage and the same changes. Okay. Then we need to take the readings. Now we will do one thing. We will take the readings. Now we will take the readings for 5 volt input. Okay. 5 volt input ku enna readings varudhu paakalam. Let me have an input probe also. Input voltage probe na vekiren. Okay. So input voltage probe vachachu. Do you want to keep change anything? Yes. Here also I am setting periodic. Okay. Yes. Then let me change the labeling for those voltages. Okay. And the voltages ku நம்ம இந்த probe ku name மாத்தலாம். இதுக்கு என்ன probe கொடுத்தா ஆப்டா இருக்கும்? இதுக்கு என்ன நேம் கொடுத்தா நல்லா இருக்கும்? EIL. Very good. இந்த probe க்கு என்ன கொடுக்கலாம்? Sorry. ILDC from ILDC simply you can keep it as IL. Here again I am going to double click over the VL probe. I am going to keep it as VL. Now let me start simulation. இது ரெண்டும் ஓவர்லாப் ஆகி ரீடிங் வருது. இது எப்படி ரீடிங் எடுக்கிறது? எனி ஐடியா? இது ரெண்டும் ஓவர்லாப் ஆயிருக்கு சார், ரீடிங் எடுக்க முடியல. ப்ளீஸ் ஹெல்ப் மீ. வாட் வி கேன் டு?
Zoom in, sir.
Zoom in. Yes. Zoom in பண்ணி எடுக்கலாம். Or else we can do one thing. Stop simulation. Move the probe little ahead. Down this probe little down. அப்போ அப்படிதான் வருதா? சர்க்யூட்டை கொஞ்சம் பெருசு பண்ணிக்கலாம். Yes. Is it clear, sir? Yes. Now note down these readings. Okay. What are the readings I need to take down? For the table note பண்ணிக்கலாமா? என்ன reading? VL RMS. என்ன சார் வருது? What is VL RMS? This is your RMS value. Am I correct? 2.730 is your VL RMS. What is VLDC? Can anyone tell me? 1.2683. Okay, very good. What is ILDC?
1.2684.
Milliampere. What is IL RMS?
2.0733.
That's all. With that, you can calculate the ripple factor. Next class வரும்போது ripple factor calculate பண்ணிட்டு வரணும். I will tell you one thing here. Since see you have a number of serial number N PL RMS in volt, then what in PLDC in volt, then IL is equal to IL RMS என்றால் IL RMS. Also equal. Okay. Output frequency. Output frequency in hertz. I think these are the readings we need to take. Am I clear? Correct? Yes. So in the readings எடுக்கும்போது I will tell you one thing. இங்க வந்து ஃபிராக்ஷனுக்கு அப்புறம் 4 digits இருக்கு. Am I clear, sir? So please round off to 3 digit and take the reading. Okay வா? அப்ப 1.2683 அப்படின்றத நீ எப்படி எழுதுவ? Round off பண்ணி. How you round off this one? 1.268 ன்னு வெச்சுக்கோ அவ்வளவுதான். புரியுதா? Yes. So that's all regarding these readings. Correct? But உனக்குள்ள ஒரு question இருக்கும். சார் இந்த half wave rectifier, full wave rectifierல அந்த waveform பார்த்தா it looks nice. Am I clear, sir? நம்ம இந்த waveform பார்க்கவே இல்லையே சார். எப்படி பார்க்கிறது? ஹலோ சார், எனக்கு இந்த டவுட் மனசுக்குள்ள இருக்கா? இதுக்கான இது யாருக்கா டவுட் இருந்தா இந்த ஸ்கிரீன் மட்டும் போட்டுக்க பார்க்கலாம். நம்ம ரீடிங் எதெல்லாம் எடுக்கணும்னு உனக்கு டவுட் இருந்ததுன்னா இதை மட்டும் ஸ்கிரீன்ஷாட் போட்டுக்கோ. ஹலோ, இந்த ஸ்கிரீன்ஷாட் போட்டோன்னா ஓகேன்னு சொல்லி ஒரே ஐ வில் வைண்ட் அப் வித் இன் 5 minutes. டோன்ட் வரி. எஸ், இதுல இன்புட்ல நம்ம எது மட்டும் செட்டிங் கொடுத்துருக்கோம் சார்? ஒன்லி திஸ். வாட் இஸ் திஸ்? V peak is equal to 55 volt. What is the supply frequency? 50 hertz. 50 hertz. Okay. Yes. Now, sir, half of the waveform பார்த்தா நல்லா இருக்குமே சார். யாருக்காவது அது மாதிரி ஃபீல் இருக்கா? நாங்கள் இந்த waveform பார்த்தோம்னா எங்களுக்கு என்ன கேரக்டரிஸ்டிக்ஸ் எப்படி இருக்குன்றதை ரியலைஸ் பண்ண முடியும் அப்படின்னு. Before that, let me ask, is it possible to see this waveform in our multisim software? பார்க்க முடியுமா? பார்க்கறதுக்கு ஆப்ஷன் இருக்கா சார்? இங்க பாருங்க, இதுல உங்களுக்கு ஏதாவது பார்க்கறதுக்கு ஆப்ஷன் இருக்கா? யாரோ ஒருத்தங்க சொல்லுங்க பார்க்கலாம். கிராஃப். எஸ், அந்த கிராஃப் கிளிக் பண்ணிட்டேன். கிளிக் பண்ணா என்ன வருது? ஒண்ணுமே தெரிய மாட்டேங்குது. வேவ்ஃபார்ம் இருக்கு, கரெக்டா? Waveform இருக்கு, but we unable to see. Am I clear, dear students? அது என்ன சார்? What are all the modification we need to do? First and foremost thing, now I am going to change the mode of simulation by interactive to transient. Okay வா? நான் சொல்றது புரியுதா? நான் எது சேஞ்ச் பண்ணிருக்கிறேன் இப்ப? இன்டராக்டிவ்ல இருந்து டிரான்சியன்ட்டுக்கு மாத்திட்டேன். Okay. Now I am going to start simulate. Then I am going to check the graph. ஒரு portion of waveform தான் வந்திருக்கு, எனக்கு full waveform வரல. கரெக்டா? Is it clear? Yes. அப்ப என்ன மீனிங்னா we need to do some settings. என்னென்ன செட்டிங் எல்லாம் கொடுக்க போறேன்? Please note down. The first and foremost thing, we are going to give what is the minimum time and the maximum time of your transient simulation period. Minimum is 0 second. Maximum I am going to give it as a 1 second. Note பண்ணியாச்சா? எதை நம்ம சேஞ்ச் பண்ணிருக்கோம் சார் இப்ப? Which one we have changed? Minimum and maximum time change பண்ணிருக்கோம். Then again start simulate. திரும்ப பார்த்தானா எனக்கு என்ன வருது? இங்க வேவ்ஃபார்ம் வந்து ஃபுல் ரேஞ்சுக்குள்ள இல்லை. ஓகேவா? இதோட ரேஞ்ச் வந்து எனக்கு டிஸ்டர்ப் ஆயிருக்கு. பிஃபோர் தட் லெட் மீ செக் வெதர் வி ஹேவ் given the 5 volt here. எஸ், 5 volt 50 hertz கொடுத்தாச்சு. எனக்கு ஸ்டில் இது வந்து ரீடிங் எனக்கு ஒரு ஃபோக்கஸ்ட் இல்லை. thereby what I am going to do, I am going to give some minimum voltage and maximum voltage in this screen. Okay va? So let me give some value as -6 volt plus 6 volt கொடுக்கலாம். ரன் பண்ணி பார்க்கலாம். ரீடிங் நம்ம கண்ணுக்கு தெரியுதா? வேற ஏதோ ஒரு செட்டிங் மிஸ் ஆகுது. என்ன செட்டிங்? 0.1 செகண்ட். நான் வெயிட் a minute. ஸ்டார்ட் டைம் எண்ட் டைம்ல ஏதோ இஷ்யூ இருக்கு நமக்கு. எஸ் எஸ் சாரி சி கண்ணா, நம்ம இங்க செட்டிங் மாத்திர தப்பாயிட்டு. டிரான்சியன்டோட டைம் we need to give here 1 0 டிரான்சியன்டோட டைம் இங்க தான் செட் பண்ணணும். இப்போ ப்ரீவியஸா நம்ம என்ன செட்டிங் மாத்தணும்? இந்த செட்டிங்கை மாத்திட்டோமா? ஓகே, let me do one thing. Okay, wait a minute. Setting, document, 1 second, 1 second. Yes. Now we are getting the waveform. What is this? Whether it is the input voltage or output voltage? Input voltage. Okay. What about this? Output voltage, rectified voltage. Am I clear? Am I clear? Hello? தெரியுதா? நான் இங்க பாரு, இது என்னோட input voltage, this is my output voltage. ரெண்டையும் செலக்ட் பண்ணிக்கிறேன். ரெக்டிஃபை ஆகி வந்திருக்கா சார்? ரெக்டிஃபை ஆகி வந்திருக்கா? Is it clear to you? Yes. If I want to measure the load current also, load current click பண்றேன், பட் அது ரெஃபரன்ஸ் கொஞ்சம் தப்பா இருக்க மாதிரி இருக்கு. இங்க போய் பார்க்கலாம் செட்டிங். So here let me shift the scale into 6 milliampere 6. Now you check the output. Go to setting, documents, order all the waveform items. Yes. Now you start simulate and check the output. ஆனா இதுக்குள்ள ரெண்டு கலர் ஹைட் ஆயிருக்கு தெரியுதா? இதுக்குள்ள டாட்டட் லைன்ஸ் அண்ட் லைட் ப்ளூ கலர் ரெண்டு மெர்ஜ் ஆயிருக்கு இந்த வேவ்ஃபார்ம்ல. Since my load current and my load voltage are same magnitude, I can't find any difference in this. Let me do one thing. Let me change the load resistor value and I will show you the different current ratings. Okay. Start simulate and check the graph. Now can you see all the three waveforms? Can you see all the three waveforms? What is the first one? Input voltage. What is the second one? Rectified output voltage. What about the third one? It is your load current. It is your load current. Is it clear? இங்க கொடுத்திருக்காங்க பாரு எத்தனை மில்லி ஆம்பியர். If I am keeping here, it shows how much volt. புரியுதா? இங்க வச்சாலும் volt. See, we only set the input voltage as a 5 volt. Am I clear? கரெக்டா வருதா பாருங்க. Peak voltage 5 volt இருக்குதா பாருங்க. 4.992 கிட்ட காட்டுது. Is it clear? Is it clear? So if you click this grapher, இத click பண்ண அப்படின்னா you can check your output. இந்த விண்டோவை if I click the scroll button, இந்த மவுஸ்ல இருக்க scroll button-ஐ front and back move பண்ணினா இந்த x axis scale vary பண்ண முடியும். இப்போ x axis ரொம்ப நேரோவா இருக்கா? Is it too narrow? Shall I increase the x axis? Yes. புரியுதா? Is it clear to everyone? Yes. The same thing I will show it in the slide once again. Please take a screenshot. So to observe the waveform, what you need to do means first you need to change this into the simulation mode into transient. Then you need to set your simulation start time and stop time. It is default. You need to change it as a 0 and 1. Start time is 0, end time is 1 second. Followed by you need to give the scaling for your x-axis. X-axis minimum எவ்வளவு இருக்கணும், maximum எவ்வளவு இருக்கணும். இங்க பாரு, minimum இங்க 0.1. இந்த minimum and maximum is your time axis. So time axis vary பண்ண அப்படின்னா time axis minimum and maximum if you vary, time axis, where the time axis, please find it. Here you have the time axis. The time axis, if you keep it as a minimum as 0, the maximum as 0.1. Start simulate, you can find this. The time axis on the range ku மாறி இருக்குதா 0 and 1 second க்கு இங்க மாறி இருக்கா பாருங்க. Time axis 0 ல ஸ்டார்ட் ஆகுது 1 ல எண்ட் ஆகுது. ஓகேவா? So likewise, by changing the transient time setting and then transient time setting, wait a minute, yes, transient time setting and then your x-axis setting, by changing this you can see your output and input voltages. Similarly, if you change the setting of the current probe, you can see your current. Okay, any doubt up to this? Yarka doubt irka? Any doubt up to this? Yarka doubt irka? Hello? No. Shall we wind up the session? அப்ப உனக்கு ஒரு கொஸ்டின், இந்த half wave rectifierல என்னென்ன நீ எக்ஸ்பெரிமெண்ட் அவுட்புட் வைக்கணும்? Can anyone tell me what are the output you need to keep? Go to schematic. Here you need to have some set of readings: VLRMS, VLDC, ILDC, ILRMS, and output frequency reading இருக்கணும். Then graphல you need to take a screenshot of this waveform. Okay வா? இதை எப்படி ஷேர் பண்றது? How to share this? How to submit this? Click this icon. இங்க மேல ஒரு share export ஒரு icon இருக்கா பாருங்க. Are you find the export icon?
Yes, sir.
Please click this export icon. Here 3 things are available. First one is the schematic image. Click the schematic image. Automatically your image will get download. Download ஆயிருக்கா sir? Download ஆயிருக்கா?
Yes, sir.
Then let me again click the same icon and click the grapher image. Yes, I am getting the second image. Yes, this is my waveform. So these things you need to submit while we giving the record work to you people. Is it clear to everyone? Is it clear to everyone? Yes, yes. That's all from our side. And do remember one thing: whenever you submit this work, rename with your register number. So register number, say example 20T101 underscore experiment number 1. Submit பண்ணணும். Likewise, you need to submit your work. Thank you very much for your patient listening. Next class we will do full wave rectifier simulation. Okay. If you have any doubts so far, you can ask, or else you can leave from the hall. Thank you very much. Thank you. Thank you.
Thank you, sir.
Yes.